I'll demonstrate how to find the derivative of a composite function. So whenever we want to talk about the chain rule, we need to take into consideration that we use a chain rule to find the derivative of a composite function. Remember, a composite function is a function inside a function, right? So um, so let's say we have d over dx of maybe f of x, f of g of x, right? So this is a composite function, right? It's a function inside a function. So what do? So we first find f prime of the whole thing. We first find f prime of the whole thing, then we multiply by the derivative of the inside function. I like calling it the inside. So that's it. That's it, right? So this represent a composite function, right? This represents a composite function. So the chain rule, we use it to find the derivative of a composite function. So now let's make it much more simple and much more easy to do, right? Let's make it much more simple and much more easy to do by maybe applying an example. So let's say we have an example. We given maybe x squared plus 4, right? Maybe to the power 2, right? So if you're given something like this, you could easily expand this to become x squared plus 4 and then x squared plus 4. Then obviously you distribute, and then when you distribute, it will give you something like x to the 4 plus maybe 4x to the 2 plus 16, right? You distribute and then you easily find the y prime of this, right, without using the chain rule, right? So this will be 4x to the 3 plus 8x, right, and then plus 0 if you want to write the 0, right? So this is what would happen if you're given something like this. But let's make it a bit more interesting. What if you were given something like y equals to x squared plus 4 to the power 9, right? So now it sort of like becomes a bit more difficult to sort of like expand this, right? So now that's where the chain rule comes in. And then in this case, I'll demonstrate two methods of how to solve something like this. So let's say, but I want to use the simple one where you can just use one step first. So y prime of this, what you would do, you take the 9 down here. So you take the 9 down here, right? And then it will become 9 x to the 2, leave this untouched, to the 2 to the power 8, multiply by the derivative of the inside. So the derivative of the blue part, what is the derivative of the blue part? It's just 2x, right? So that's your final answer. So another method that I find very useful, it's that maybe let's say you're given the same problem, but let's do it in writing this time. Let's say you're given y is equals to x squared plus 4 to the power 9, right? So let's make the inside, let's make the blue part to be our u. So let's make this to be our u. So what is this? This is x squared plus 4, right? What is our u prime in this case? It's just 2x, right? Or actually, let's not use u prime, let's use du over dx, right? It's still the same thing. It's the same thing. But what is our y? Our y is, if we make this to be u, our y, it will become u to the 9, right? So dy over du becomes 9u to the 8, right? But what are we looking for? Are we looking for dy over du or du over dx? No, we are looking for dy over dx, which becomes dy over du multiplied by du over dx. So you can see that if we were to cancel these two, we'll be left with dy over dx. So that's not how we approach it. What is dy over du? Dy over du is 9u to the 8, and then what is du over dx? It's just 2x, right? So but we're looking this in terms of, we're looking for our answer in terms of x. So let's substitute x where there's u. So this becomes 9. What is our u? What is our u? It's x squared plus 4 to the power of 8, right? Close bracket, multiply by 2x, right? So if you see that the answer we got at first and the answer we got here, it's the same thing, right? So these are the two methods that you can apply when finding the derivative of of the of a composite function using the chain rule. So yeah, let me know what you think. Don't forget to subscribe.